Hello, I'm Victor Schott, ATS Applications Engineer. And I want to welcome you to this month's presentation regarding Edgecam's latest features for 2010 Release 2. One of the things that's always important are supported operating systems. With this release of software, Edgecam can run on Windows 7, Professional, Enterprise, Ultimate, Vista, and XP Professional using Service Pack 3. Edgecam still remains a 32-bit application, but will install on 64-bit operating systems. In the area of optimization, the background processing takes advantage of multi-core processors in today's PCs, which also helps reduce the unnecessary regeneration of cycles and toolpaths. In the area of Feature Finder, the hole features has been greatly enhanced, where you can find all holes. This creates CPLs from which you can index to in 3+2 type programming or horizontal machining centers. The ability to define an inside bore hole, the improved CAD link, data transfers, limits and fits from the hole wizards from the CAD packages, Inventor, SolidWorks, Solid Edge, to include taper hole threads or MPTs. On the mill side, we've had open pockets, but now we also have the open mill. If you think of a slot where it's open on either end, that can be defined as a feature, as well as flat faces that can be machined using the roughing, face mill, and flatland finishing cycles. Some of the turning features includes groove profiles for the ID, OD, and the face, as well as ID bore and thread faces, again from the CAD link data supplied by Inventor, SolidWorks, and Solid Edge. So let's take a look at some of these features as we load a part model file, which is a parasolids based solid model created by Edgecam's part modeler. We'll see that there's several feature types here, to include the channel or slot at the top. And when we conduct a feature find, what we can do is have Edgecam look at the automatic selection. In other words, if there were multiple solids here, i.e. fixtures, stock, Edgecam will automatically determine which one is the component to be machined from, whereas in the past you would be prompted to pick the solid model. So again, in this case we've only got one solid, so we'll select that. Under our mill features tab, as you can see, there's a find all holes. The vertical and find radial is relatively new. You have to determine which axes you want the radial holes to be found about. There's the internal bore option. Of course, the maximum diameter is still the same, the 2D pockets, bosses, etc. But now we also have the open pocket and open mill. Those have to work in conjunction with each other, as well as the flat faces. The display tab remains unaffected. So as we pick OK, even though we initially started in the top plane, Edgecam is looking at the entire solid from all the various angles to find the hole features as well as the radial hole features. So in the case of the hole on the right side, it should probably be found in relation to the right CPL, and the internal bore holes would be found from the inside out, as opposed to in the past you probably would have to have created a manual feature. So here again are some pockets. You see the open mill pocket where it looks at the floor of the feature and builds up the walls from that. There's a 2D open pocket. This can be nice as well. So if you rough this out, there's the option in the roughing cycle that prevents a rollover condition, so the tool will move straight in and straight out. The blind tapped hole that we're going to look at here, if we edit this, what we'll notice is from the CAD modeler, again this is part modeler, but it could be Inventor, SolidWorks, Solid Edge, you see that it was defined as a 3/8 NPT under the thread tab. It has the appropriate nominal size, drill size, the standard that was used. The thread depth here again was defined in the CAD modeler, and as you can see there's numerous standards there to work with. In this case you can see the internal hole features that obviously if you're equipped with a right angle head or some other attachment to drill those, you could do that easily. One other thing I want to touch on here is this CAD link data that's usually misunderstood. As you can see, the work planes and sketch planes have been transferred from the CAD system, again the ones I've been mentioning, and as you can see here we just created a sketch plane called G54. So in that drop down list you can easily select that and define where your coordinates are going to be relative to or from. So this is another nice tool that can be used that people don't often take advantage of. All these work planes and sketch planes were used to create this solid model. So again, if you had one just defined as a G54, 55, P1, P2, whatever, you could easily select them from the list. Since it's a user defined CPL, you can rename it as well. Now if we look at some of the turn features, we'll load a file here. And one of the unique things you'll see is that with Edgecam's part modeler, within the modeler a stock definition was created. So therefore when this was opened up in Edgecam, it automatically knew what the stock was. So you don't even have to define stock now. In this case, as we can see, we've got a turn and mill tab assigned, and we're looking for features in the axial, reverse axial orientation, as well as another option allows us to digitize a face where Edgecam will look normal to that face and find any features based on our selections. So in this case we have an angled face there. We're going to automatically select the component, and in the turn you can see that we're using just turn feature, we've got a face feature, and grooves. So obviously depending on what we select, that will dictate what is available to us in the dialog box. These options are pretty straightforward. So for our turn feature, if we want to start on the face of the part based off of the maximum X, we're going to move to the maximum X end, as well as the groove, basically a maximum width and depth. On the mill tab, here we're not necessarily interested in some of these options. We don't want to find all the holes. The diameter may be an issue, we can step that down. We don't need to look for radial holes necessarily. There should be one 2D pocket. The reason we're looking at the tapered face there, as you can see, it prompts us to select an individual face to pick. Edgecam is going to create a CPL normal to that face. Because it is at a tapered angle, the radial CPL would not apply. The feature find CPL was created, and you can see then if you make that active, you'll notice how it's been aligned with the, or normal to the face that's been selected. In your B-axis type machines, you can now index to that face, that orientation. It will give you the proper B angle. You could then mill, drill, whatever the case may be. As you can see here, the other features, if you go to a wireframe rendering, you can also toggle your features so you can easily see what's been found and in what orientation or in relation to that particular CPL.